So the now next question is the 16th question. Okay, so what is the 16th question? 16th question is the mass is given. Okay, you see there the mass is given. Okay, so the mass is given here. Mass is m. Okay, mass is m. Velocity is constant. Velocity is also given. Mass is also given. mv. Now they are asking what is the work done on the object in order to bring it to the rest. Okay, so v is the initial velocity now, and the final velocity rest means final velocity v is 0. So u is given u, m is given m. Now they are asking work. So if here velocity is given, so if velocity is given, I have told you which formula you will use. In this, force and distance is not given, so which formula you can use? Half m into v square minus u square. Okay, so this one is 15th, 16th. Okay, so see, this was the third formula. Okay, first is fs, second is fs cos theta, third is half m into v square minus u square. So initial velocity v, final velocity 0, m, mass is given m. Okay, so this is the work energy theorem and third formula of work. So half m v is what? V square minus u square, so it is what? Half m v square. Okay, half m v square, that is the initial velocity. That is the answer. Now the next question is the 17th question. 17th question is what? You have to calculate the work. So again, work you have to calculate to stop a car. Stop a car means what? It is the final velocity. So some means it is work, it is going, you have to stop. So final is 0, initial is 60 kilometers. So it is moving at 60 kilometers. So initial velocity is 6, final velocity is 0, mass is 1500. Again, velocity is given, you have to find out work. So same formula you have to apply which you have applied in 16th. So half m into v square minus u square. Okay, see here what is there? It is given in kilogram, that is okay, that is SI unit. Kilometer per hour, it is in kilometer per hour. So what you have to do, you have to change it into meter per second. Why you have to change? Now tell me. You have to calculate the work. Okay, this is in kilogram, no, so both units should be in same. With kilogram, kilometer per hour is not coming. With kilogram, meter per second is coming. Okay, so that's why whenever, okay, you just learn this, with kilogram you have to apply a meter and second. That's why you have to change it. Now u is given 60 km per hour, v is given 0. You have to calculate the work in joule. So joule is also meter, so you have to calculate in meter. So change it into kilometer, from kilometer per hour change it into meter per second. Now same formula you will apply. So this is u 50/3, v is 0. So you will solve this, you will get 2.08 into 10 to power 5 joules. That is the answer. Okay, so actually it came 20830. Okay, so actually we if you want to like simplify, you can write on this also, this joule, you can write on this joule also. But if you want to like change it into the decimals, so how we are changing it into the decimals? See, after 208 you are having 3 zeros, so it is coming, how we are writing in mathematics, into 10 to power 3. How many 10 are there? 3. So 10 to power 3. Now if I want to put point here, means decimal here, what I will put, I want to put point here after 2, so I need 2 zeros. So if you will divide by 100, also you have to multiply by the 100. Okay, so 208 by 100 into 100. Okay, so with 100, point will come at 2, and this 2 zeros will add into 3. 10 to power 3 plus 10 to power 2, 10 to power 5. This is like decimal conversion that you have to learn in mathematics. Okay, so again, if you are having any doubt in here, see, don't worry about this, you can write on this also. Okay, so if you don't understand this one, then you can write on this also. Okay, now comes to the question number 18. What is the question number 18? 18 is, you have to find out where the force is positive, negative and 0. This is simple according to the table. Okay, they are perpendicular, FNS is perpendicular, so theta is 90, means angle is 90, so work done is 0. Here both are in same direction, FNS, so it is positive. Here both are in opposite direction, it is, so work is negative. Okay, now next question, question number 19. Sony says that acceleration could be 0 when several forces are acting on it. Do you agree with her? So they are saying if more than one forces are acting on one object, okay, so whether acceleration can be zero. Yes, it can be zero, because see, if you will think about one object, okay, you are like you are pushing it, so you are applying the force, but that object is also applying a frictional force. So both forces are like in class 8 you have learned force is equal to frictional force, means both are equal and opposite to each other. If you will neglect g, means gravitational force, you will think about f and f. So what will happen, these two forces will cancel out, and it will, the acceleration will be zero. You can think about it. See here, the force will become zero here. If force will become zero, then a will also become zero, no, because see, f and f, this is the object, okay, you are applying capital F, this object is applying small f, both are equal. So if total force, you will think about this, okay, neglect any other force, just think about these two forces. So what will happen, f plus f, so both will cancel out, f minus f, okay. So this total force will be zero. If total force is zero, f is zero, then f is what, ma. A will also be zero. They are asking whether in any normal situation have you observe anything where acceleration is zero. Acceleration can be zero. How it can be zero? If all the force, if I will give you one object and I will say, okay, 10 forces are acting on this, but all the 5 will cancel out the 5 minus 5, then it will become 0. Means if any object is having 3 forces here and 3 forces here, they both are in opposite direction. See, it is in this direction, it is in this direction, sorry. So both are in opposite direction, so these forces will be positive, these forces will be negative, they both will cancel out, and then the force will become 0. If force is 0, acceleration will be 0 only. This you have to learn. If they will ask the question whether acceleration can be 0, you will say yes, it can be 0. Now the next question is 20th. You have to find out energy in kWh. See, if household will come or kWh, what you will write down? You will use a formula of household energy. That was what? P into T. Okay. Now see, they are saying 10 hours by 4 devices. So what? Each. Okay. So you see, the power of one device is 500. So what will be the power of 4 devices? Simple mathematics, 4 into 500, that will be the total power. Now they are saying 10 hour they are consuming, means 10 hour by the total pair. So power, you got power 500 into 4, time you are having this one. What is the time? 10 hour. Okay, so how you will find out? You will find out like this. Okay, now you will find out. See, time is given 10 hour, quantity is 4, one device power is 500, so multiply it, it will become 20,000. Now they are asking about what is energy, so find out the energy. What is the formula of household energy? It is power into time. So see, what is power, this time, what is 10. Now it is coming in watt hour. Think about it, it is coming in watt hour because it was given in watt. Now we have to change it into kilowatt. So 1 kilowatt, kilo means 1000 only. Okay, so kilowatt, 1 kilowatt is 1000 watt. Okay, so find out the value of 1 watt. It will be 1 by 1000 kilowatt. So put it in this one, 2 into 10 to power watt hour. Okay, change watt into kilowatt. So 1 watt is 1 by 1000 kilowatt. Okay, so put it here, it will become 2 into 10 to power 4 into 10 to power minus 3. How 10 to power minus 3? See, 3 are downside. Okay, so if they are downside, you will send it to upside. What will happen? 10 to power 3 is positive. When you will, it is positive 10 to power 3 plus. Okay, when you will send it upstairs, upwards, it will become 10 to power minus 3. Simply, if I will say, okay, suppose 1 by 10 to power 1 by 100 is there. How you can write down this? You can write down this 1 by 10 to power 2. 2 10 are there, na? 2 0. So 2 times 10 you will make it. 10 into 10, 100. Okay, so this, if I don't want to write it in the fraction form, means 1 by 10 numerator denominator, so how I can write down 10 to power minus 2, means this power, when you will take it to the upwards, it will become minus. This is general mathematics. Okay, so this will be the answer in kilowatt hour. So So where you have to read the question very carefully. What they are asking, they are not asking in watt hour. Otherwise, this will be the answer. They are asking in kilowatt hour. So you have to change it in kilowatt hour. Now the last question is, a freely falling object eventually stops when it will reach the, means I'm just throwing one ball, okay, releasing, I'm standing on a roof and I'm releasing a ball. So what will happen when it will hit the ground? It will stop, means its velocity will become 0. So what happens to its kinetic energy? The kinetic energy will change into the potential energy. See this one, this I made, that is like the perfect thing. Now see, when it is on the, like when you are keeping it anywhere, like this is the roof, okay, so now it is not moving. So when it is not moving, it is at rest. It is having which energy? Potential energy. Why energy? Because all the atoms inside it, they are having one energy, that is known as potential energy, energy of rest. When you will throw it, what will happen? It will come in free fall. Free fall means it is falling down, okay. So when it is falling down, it is in motion. So now this potential energy will change into kinetic energy. Now what will happen? When kinetic energy, when it will hit the ground, you will see it will not come into rest immediately. So it will not, kinetic energy will not convert into potential energy at that time. What will happen? You will see when the ball will hit ground, it will move in like curve direction, okay. In the cricket also you will see, it will not come, it will not immediately stop. When it will fall down, it will not immediately stop, it will just bounce back, okay. So when it is bouncing back, what is happening there? You will see, if you will touch the ball, no, it will have something warm, it will become warm, okay. It means what? Heat energy will be there, and you will hear a sound also. So this kinetic energy will change into heat energy and sound energy, and ultimately when it will come to the stop again, it will have the potential energy. So this was it. So your chapter is finished. So next I will post the notes of the sound, okay. So revise this questions, all the questions and text and exercise question I have given, plus the exercise class note also. In case of any doubt, just send me a message, but revise it because questions will come from this chapter, okay.